horizon on your investments, I'm going to tell you a limit such that using the historical data, I'm going to be 99% sure that you're not going to lose more than a certain amount. I'm going to ask myself the question, answer the following question. As the risk manager, and this could even be in a portfolio, you're managing a mutual fund and you assign certain traders to certain assets. You want to tell them, I want to be 99% sure that using your trades on this one, you're not expected to lose more than $1 million. If you can be 99% confident that you will not be losing more than $X, what should be the trading limit? First, I'm going to ask myself a question. If the trading limit is $1, at what numbers I'm going to be 99% sure that I'm not going to lose more than that? If $1 is invested, at what $Y I can be 99% confident that I will not lose more than $Y. And you could be making money, obviously. That means probability of my P&L being less than minus $Y is 0.01. Since I said lose, when it comes to returns, it's negative, that number. Then negative $Y would be equal to first percentile. SPY case, I'm going to think about the actual right now. $6.66. .01 mu sigma, okay? And we know that to be about 666. Or $Y is 666. We know that 1% of the time, on a given week, negative, I'm sorry, not negative, 0.6066. 6.66% of $1. Fine. Now, the question is, the max I am willing to lose with 99% confidence is $100,000, let's say. So I don't want this trader to cost me more than 100K a week, kind of almost worst case scenario. 99% of the time, I want to expect that he's not going to lose more than 100,000. Because this is only 1 week. If I'm not happy with him, I can fire him next week, right? So I'm going to ask the following question. 99% of the time, if I invest $1, I'm going to lose, $X is the trading limit. Well, I'm sorry, it's more like position limit. So if I invest $X, my max loss with 99% probability is 0.066, and I want that number to be $100,000. So my trading limit is quickly calculate that. About 1.5 million. In fact, had I increased that to about for some reason highlights is not working. It's a nice little way of figuring out the trading limits. Now, I kind of want to segue into pretending that this data distributions were normal. If we pretended that outliers in the data were similar to normal distribution, as a lot of risk managers have done in the early parts of 2000s. Let's see what would have been the trading limit and what would have been the cost of that assumption. If we assume that data was normally distributed, because there is a lot of statistical machinery for that. Again, for individual stock, it's not much of a problem, but in many cases, when you have a portfolio that comprises complex derivatives, a lot of the pricing machinery is done under the assumption that asset returns are normal. Trading limits would have been larger. Because the formula is kind of trading limit is max loss divided by negative of VAR 1 minus alpha %, where 1 minus alpha is confidence. So in this case, under normal, negative of VAR 1 minus 99%, 0.0539. So trading limit would have been 100,000 divided by I'm gonna round it up to 1.855 thousand. This means, given your risk tolerance, and your risk tolerance is determined by you, you say, I am willing to lose at most this much, that's your 100,000, and you want to be 99% confident that it's not going to be more than that. And that number is also your choice. You can pick 95, you can pick 98. Typically, it's not a bad idea to have kind of different trading limits, but at least at a minimum, just have one number. If you pretend that, if you're lazy as an asset manager, and you don't look at the actual distribution of the returns, and you say, okay, I'm just gonna estimate mean and variance. Given that, I'm gonna tell you your trading limit, because I'm gonna assume it's normal. Well, if you do that, you're gonna go ahead and get a number that says 1855. But since the tails are fatter, those fat tails will lead you to take more risk than you thought you were taking. Because the actual tail risk is higher. And this is actually a name for that. You're basically, assuming that it's normal, assumes that there are no black swans, okay? Most swans are white, but there are also black swans. But red, under normal distribution, all swans are red. But under non-normal distributions with fat tails, some of the swans are black. That means the chances that something really drastic happening is much higher in actual distribution compared to assumed normal distribution.